I'm going to briefly describe how to use this interactive simulation for a CSTR and some of the important things to keep in mind about a CSTR is that the feed coming into the reactor, and we're using molar flow rate, so F is molar flow rate and C is the concentration at the inlet, and simple A goes to B reaction. Things to notice: the concentration leaving is identical to the concentration in the reactor because we're assuming it's completely well mixed. And what this means is once the feed enters the liquid in the CSTR, it's immediately mixed and there's a step drop in the concentration of the reactant feed. And what the simulation does, it allows us to change the volumetric flow rate, and changing the volumetric flow rate changes how much time we have for reaction. So if we increase the volumetric flow rate, we're decreasing the residence time, tau, decreasing how much time is available for reaction. So we're going to have less, smaller fraction of the feed converted to product. If we increase the rate constant, well, then reaction is going to go faster, and we're going to have a lower concentration of the reactant in the product stream. And we can also change the concentration entering the reactor. And finally, we can do this for first or second order. Couple things. We're assuming liquid phase, and this means the volumetric flow rate. So the molar flow rate of A would be the concentration of A times the volumetric flow rate. We're assuming this is constant. So let's look at the simulation and see how it behaves. So here's the interactive simulation. I can increase the flow rate with this slider, and you can see the residence time tau decreased, and therefore we had less reaction. I can increase the rate constant, and the concentration of the reactant decreases and its flow rate leaving decreases. And then I can change from first order to second order, and in this case we're keeping the rate constant the same. The units are different, just to make easier to make a comparison. And for second order, of course, concentration coming in is going to make a bigger difference in how much reaction takes place. So the idea is for this isothermal reactor, and that's important to keep in mind, we can look how changing these three variables affects the flow rates of reactants and products leaving the reactor.